The chloride anomaly is a relatively unique situation when your redox table doesn't predict as you would hope it would. That's what an anomaly is. It just doesn't make sense. It's an unexpected result. So when we have aqueous sodium chloride, we were trying to figure out what the net reaction is going to be, what is going to occur at the anode or cathode. You can be asked any number of questions. When you're predicting redox reactions, no matter the scenario, we always list our entities first. Always, always, always. So we have sodium ions, we have chloride ions, and we have water. Okay, nothing fancy there. So then we use our table. This is an OA, this is an RA. Together these are an RA. Water is both oxidizing and reducing agent. Okay, fine so far. Then we decide which is the strongest of each. Well, between sodium and water, water is my SOA, okay, as normal, as predicted. However, this is where the difference is. Although water appears to be your SRA on your table, it is lower down than chloride. Okay? However, when you have just chloride and just water as your only two reducing agents, okay, if those are the only two reducing agents you have, then the chloride acts as the SRA. Okay, that's a very important point. We see that a lot on testing situations, whether it be unit exams, finals, diplomas. It's a pretty common representative. Doesn't have to be sodium chloride. Often it is, but as long as the only two reducing agents available are chloride and water, you're going to get this chloride anomaly occurring. So as a result, instead of producing harmless oxygen gas, relatively harmless oxygen gas at the anode, you would produce chlorine gas, which is quite harmful. And another thing that you are often asked about cell scenarios is what evidence of reaction do we have at the anode and the cathode? Well, with the chloride anomaly, instead of just having oxygen being produced, which is a flammable gas, we would get chlorine. And so some things that you might note, if you remember evidence of chemical reaction, well, we have hydrogen gas being produced at the cathode, and we could test for that because it's an explosive gas. Then we also have hydroxide. Well, that sounds like a base to me. So we could test litmus. Red litmus would turn blue. Or if we had a pH meter, we could be a little more accurate. Another thing you often see, which is a bit of a trick question, is what happens to litmus paper at the anode? Well, most people think nothing because you don't see hydronium or H+ or any example of acid or base being produced there. Well, chlorine is a bleaching agent. And what does bleach do? It turns things white. So if you happen to see a question asking what chlorine does to litmus, it turns it white. Which is pretty neat to think about.